This is a LED cube I'm going to be building over the next few weeks. It's a big project. I got it on eBay. It's 4,096 LEDs that you solder together in a cube. I built a smaller one of these about 2 years ago. It was about 512 LEDs. It was a lot of fun. It was definitely some work. This one's going to take quite a bit more work to put it all together. I got it from the same seller that I got my smaller cube from. It worked out well. He responded to questions when I sent him an email. They don't give you great documentation. He gives you a link to a Google Drive account to download some photos and a video, but it's not great. It's going to require filling in the blanks and just staring at it for a while until I understand it. What you get with this particular kit is a circuit board. Interestingly enough, this circuit board's complete. The other one I have to solder the chips and the resistors and the switches down. This one's all done. I suspect they do it because this one's using surface mount technology. The other one was using larger components. It was easier to solder. This would be difficult, I think, for a home user to do this kind of work. It looks well made. The circuit board, like the other kit, is the template. There's a bunch of holes drilled in here, and you're going to place the LEDs in these holes, and that's going to help you build the template so that you get everything nice and square and lined up for these LEDs. The kit comes with a few bags of the LEDs. As you can see, quite a few of them. It also comes with a miscellaneous parts bag that has a wireless remote, some sockets that are going to be soldered to the board to plug in the LEDs. They do not include a power supply, so you have to provide your own 5-volt supply. I will be filming pieces of the construction project as it goes along. One thing I've already noticed that's different on this kit is there's no riser boards. The older kit that I built, you had these boards that came up on the side, and that's how you anchored all of the LEDs to these riser boards. In this case, they just include some wire in the bag, and that's how you're going to get the voltage to each layer of the LEDs going up. I'm a little disappointed about that because the riser boards acted as a good girder to keep everything nice and stiff. In this case, there's going to be nothing to help support those LEDs going up, so that's going to be a little different. Here's what the other project looked like that I built from this same eBay seller. And this has been going for almost over 2 years now straight. It's a lot of fun just staring at it. So I'm anxious to see what this one's going to look like, since it's going to have 4,000 plus LEDs on it. So looking at the parts bag more closely, what I found interesting is they include 2 chips. I'm assuming these are spare chips that could replace these chips on the motherboard, because there's no open spaces to solder these 2 chips on. So I'm assuming they're spares. The other thing interesting about this board is it has a SD card slot on it for a memory card. These are switches here. I don't know what they do yet. It has an input jack over here, and it has a USB jack and a power cord here. The larger LEDs are like the other model that I built. They act as the feet. This is the bottom side of the board. So when it's all built, it'll be turned around and it stands on its feet, which is the LEDs. And those LEDs are multicolored. They actually change. Oh, and there's actually printing on the board. So, okay, so we have an audio button, an effect button, and a text button, memory card, USB, 5 volts, and audio, and audio out. Okay, this is the 3D cube that has 4096 LEDs that have to be soldered together. This particular layer is almost done. This is a 16 by 16 grid, and I just have to finish off the last row. And I just want to show what the technique is for soldering these together. This is the sixth one I've done, so now I've got it down pretty pat on how to solder them. It's a lot of tedious work. It's not very hard, but you definitely need to know how to solder to do this. First thing they have you do is, when you look at the manual, which isn't much of a manual, they have you look at the board, and it's labeled audio in here and audio out on this side. Put that in the left corner of where you're sitting. Then, using the LEDs that are provided, here's an LED. They want you to bend the negative lead flush with the LED. The negative is the short lead. The positive is the long lead. So what I do is I hold it in my left hand, and then I just bend this over so that it's flush with the LED. There's no step in it, and get it about 90 degrees. Then, using a pair of needle nose pliers, give yourself about 1/8 of an inch of a gap, approximately like that much, and then just bend it over at a 90-degree angle to the other LED. Now in this case it didn't come out as 90. It's no big deal. Just grab the LED and bend it until it's about 90, and also make sure they're about 90 this way. You can fix it later if they're not. But you want a small step on the positive LED lead. This leg here cannot touch these legs. It has to be soldered to this leg here, and it has to go above these. So that's why you need a small bend in the positives. Because if this touches that, it's not going to work. It's going to be a short. So I'll do one more. Take the LED, I hold it in my left hand. I take the short leg, bend it flush with the LED. Needle nose pliers, do about 1/8 inch, and then just bend it this way towards you. If it's not 90, square it up. You can see the small rise in that, and then just drop it in a hole, and we want to get all 16. So what I do is, when I have all 16 in the board, I then will test each LED with my multi-tester, and I'll come back and I'll show that in the next step. And now I have a complete row done here. So what I'm going to do, before I even solder them in, there's always the possibility when you're doing this many LEDs that you make a mistake. I have a multi-tester here that can do diodes. So I put it on the diode function, which is that little icon there. I have to hit the select button to actually get it to diode. Now this is going to provide voltage out the probes, and the negatives are over here. I'll push the board up so you can see it better. So I'll put the negative here and the positive, and you'll see the LEDs light up. I want to make sure that I didn't accidentally put one in the wrong direction or bend one the wrong way. So I'm just going to quickly go down the line and make sure they all light up blue. And we're good to go. Now, what I've done here that I like to do is that the first one's always the trickiest because there's nothing holding anything in place. So just line it up and you want to make sure you use a clean iron tip. Have a sponge, a wet sponge when you clean your iron. And what I do is I put a drop of solder here, and then you might have to line up the lead better so it holds it. This case it did move on me, so that was good. And then I go down the line and I put solder on each one. I'm just going to do 3 for right now. I don't need to do the whole set. Okay. Then this leg here, the positive legs, you have to make sure that the positive legs do not touch the legs below them. If they touch these legs here, that's a short. That's why they have you bend the positive leg with the needle nose pliers, where it's slightly risen. It can't be flush, because if it's flush, it's going to touch the other LEDs, and then it's not going to work. So you have to make sure on each one of these that before you solder anything, you've got to get them lined up with these legs here, and you want to make sure there's no space in there. If there's a little bit of space, bend it and then pull it back so that it acts like a spring on the LED that it's being soldered to. You want no space in there. You want to make sure there's a good solid connect. Then take your iron and drop a small amount of solder on there. I'll do another one. Now you can see here this leg, camera may not pick it up too well for this angle, but the leg is going down towards the board. So we're going to bend it up. It now has a small gap in there. So we're going to bend it towards me, then bend it over back to the other side so it acts like a spring on there. Now you can see it's flush with the wire. Now you can hit it with the soldering iron. And what I do is I do a whole row going across, and then I put my finger on each one, a small amount of pressure. If you don't get a good connect, the solder will snap right off. You'll know. So just go down and touch each one with a little bit of pressure, this direction, and the ones that are above them. Put some pressure on it. If you don't have a good solder connector, it'll go pop, and then you'll know you have to redo it. And then you want to go down the line and do every other LED like that. Okay, once you've finished a complete 16 by 16, it's not that easy to get this out of the circuit board. If you just try peeling it up from the corners, you're going to bend these pins up. So I recommend taking a popsicle stick. It will fit between the LEDs, and just twist the popsicle stick to about a 45, and then go every other LED. Do a twist and gently pop them up. Don't pop them up all the way. And then just keep rotating the board. If you try pulling it from a corner, you're probably going to break a connection. You're going to bend the leads. As you can see, it takes a little bit of effort to get one of these out of there. There we go. And that's it. Now it's popped it out. And you may want to visually inspect it, or you may even want to run the multi-tester one more time on each one and make sure none of the solder connections actually broke loose, because it does take quite a bit of prying to get one of these guys out, and it's possible that you may break a connection while doing it. Okay, that is what 16 layers of LEDs looks like. 4096 LEDs have been soldered together to form a square. Okay, so the next step after soldering all the LEDs together is to put these little insertion pins on the main board. This is actually the top of the board. The bottom of the board is where you see these jumbo LEDs. Those act as the feet. So you're going to take these little pins and put them in the holes, and then you have to solder each pin in. Okay, so the next step before installing they call these levels, onto the board, you want to take the level. These are the negatives, these are the positives. You're going to bend the positives forward towards you, like this, and just get them about 90 degrees. They're going to get soldered together later on and during the assembly. So just bend them forward. Doesn't have to be too accurate right now. Okay, once you have them all bent forward, the next step, getting them into the circuit board, is fairly challenging. I found one trick that's worth doing. Is these little insertion sockets are like spring-loaded, and it's kind of tough getting the LED in there. This thing is like a noodle. They're very soft and wiggly. Everything moves around. Take a spare LED, and they give you plenty of spare LEDs in this kit. The documentation says they give you over 900 spares, which I can't imagine why they give you that many, but they do. I finished soldering all 16 levels, and there's a whole bag of extra LEDs left over. It's kind of excessive to give you that many extras. Anyway, take a spare LED, take the leg, hold it in a pair of needle nose pliers, and just push it into these sockets just once. That will help the leads go in a little bit more easily, because the first time you push it, it's a real snap to get them in there. And this will make it a little bit easier trying to get that level into the sockets. Now, with the leads bent over, those are the ones obviously not going into the sockets. You take the negatives and you have to get them in there, and it's a little crazy. I start on an end and hold it at a slight angle, and then I work them in. I'm not going to do this in front of the camera. It's going to take me several minutes to get one level in. It's not easy. It's just difficult. The leads get caught on the edges of the sockets, or they're on the outside of the edge. Not all leads are exactly the same length. It's challenging getting a level in. And you want to make sure that every pin is in, because as you can see how thick this is getting, if you miss one, there's no way to get in there. You're going to have to pull everything out to fix one. So you want to make absolutely sure that all 16 leads are going into those sockets. Okay, the next step is soldering all of these leads together on each row. It's quite a bit to solder. And the problem is these LEDs are just, as you can see up in the top, they're just moving around. They're all over the place. So I cut out some aircraft plywood that you can get at like a Joann's or a Michael's craft store. I cut little slits every 14.5 millimeters spacing. I measured the spacing on the pins. And this helps keep the spacing even between each level or row of these LEDs. And that'll make it neater when you start soldering these leads all together. So the next issue was, after I got the top row soldered, soldering the rest of the rows, you want to keep the spacing even. And with this thing, mounting it sideways, it didn't work, so I had to flip the whole cube on its side so that this stays on the top, because otherwise the spacing will get all uneven on these LEDs. Okay, so once you have all the leads soldered on the side here, going down this way, this is nice and rigid over here. Nothing moves around. The problem is the other side is like a noodle. It moves around. So I have the spacer in here right now to keep everything evenly spaced. I'm going to take some of those spare LEDs that they provided, cut the legs off of them, and I'm going to put bridges between each spacing here. These are all joined together electronically anyway. So if I put a soldered bridge between each layer here, that will keep them from knocking each other, because without this spacer in here, they move all over the place. It's very flimsy. I'm doing this right now in the middle. I'm using a third hand to help hold a leg from an LED in place, and then I solder it on both sides. And I also did it on the ends here of the cube, where every layer I put a leg. And now that makes the cube, first of all, it makes it more consistent looking because each layer is evenly spaced, and it makes it a lot stronger. It's not going to wobble all over the place. The next step is to wire up these wires. There's pins going down the side that are labeled 1 to 16, but pin 2 goes to level 2, pin 3 goes to level 3, pin 4, so forth. So they give you plenty of wire here to do this. Okay, so this is what it looks like with the wires going up. This was pretty easy, no big deal. Just got to make sure you go up in a step. I accidentally got off base around here and had 2 on the same layer, so I was 1 short at the end, so I had to redo the links. So the last step, disappointingly, I'm a little stuck. I don't know why, but they do not include the power connector. So I sent the message to the merchant, and he gave me the specs for it, the inner diameter, outer diameter. So I've got no way to plug into the connector. I might just jumper something off the solder joints for tonight if I want to power it up and see if it works. Surprisingly, they want 6 amps. I can't believe this thing actually needs 6 amps, but we'll see how that goes. So the final step is the power supply, which is not included with the kit. You need to buy a supply which is going to look something like this, and it needs to be 5 volts at least 6 amps. I was quite surprised that this kit needs at least 6 amps. I tried it with a 3 amp supply that I had laying around, and it does not work. They also, surprisingly, do not include a power jack. That's the connector on the side of the board here. This guy right there. That is not included. So I had to send a message to the seller, and he came back and told me that the jack is a DC005. That's the connector on the board. So the actual connector is 5.5 millimeters by 2.1 millimeters. The 5.5 is the outside diameter of the connector, and the inside of the connector, the hole, is 2.1 millimeters. So you need to buy this separately. I picked these up on eBay. They were easy to find, no big deal. The one I got is 10. I didn't want to take any chances. I used a couple of different power supplies initially trying to get this thing to fire up, and it does need 6 amps. I was quite surprised. I have an old Heathkit power supply, and I joined the power supplies together to create more amps, and I still couldn't get it, even with a 3 amp power supply on top of the heat kit. Alright, so the Cube comes with a remote. Disappointingly, the remote does not come with a battery. I looked at the back and it says it needs a CR2025. Luckily, I had one laying around, so you're going to need one of those. I'm very surprised that they don't include that with the kit. Okay, so we're ready to power up the Cube. This is what it's going to look like when you first power it up. Now the surprising part is I've built another one of these kits from the same seller on eBay, and I assumed that the demo was going to be a variety, which it's not. This is all it's going to do with the built-in firmware. It's just going to do that little gyration, and it outlines the outside edge of the LED on all the corners on the sides. That's all it's going to do. I was a little surprised. I pressed different buttons on the remote and nothing changes the demo mode. What you have to do is get a micro SD card. They call it a TF card. One of these guys. And you have to copy certain files to the micro SD card, which I'll document later on. And then when you insert this memory card in the TF slot, this is the demo that's actually on the software, which is a lot more interesting. Now this software does not come with the kit. He sends you a link on a printed piece of paper that you have to type in. It's a very long link. It's kind of awkward to type it in. It's to a Google Drive share. And that will allow you to download this PC software, which has a few files on it. And again, there's no documentation. It took some random attempts on my part to figure out what files had to be copied to the memory card for this to work. I also didn't understand the format of the memory card. If it needs to be FAT, FAT32, exFAT, no documentation. The interesting part is if you plug in a card that's not formatted correctly, it will draw a circle with an X through it, which is a pretty clear sign it doesn't like the card format. The demo, I haven't timed it. It's quite long. It does a variety of different patterns and drawing shapes and does some words and lettering. It's pretty interesting. Okay, so the files that you have to copy to the card are these two files here. The 3D16 animation data.dat. I don't know about that file if you have to copy it or not, but I did. I tried different files on the card and I found that the DAT files are the ones that it pays attention to. Again, there's no documentation. They give you no clue what to do here. They also give you some animation software. It's version 1.0. I tried running it on Windows 7 and Windows 10. I can get the executable to run, but you can't save a file. It always gives you an error when you try to export a file. So I was not able to try anything. The one thing that I'm disappointed about is my other Cube had a way of lighting every LED up on the Cube itself, because I'm not sure if I would have a dead LED in here. It's too hard to tell from the demo mode if every LED is working. I would like to write a short program just to turn on every LED, all 4096, so I can confirm that they're all working correctly, but right now there's no way to do that. Also, the memory card, the pins, this is how you install it. Pins up, not pins down when you plug it into the card slot. It has an audio in jack in the bottom here. I tried it with my cell phone. I brought up some music. It's very boring. It's not a very interesting animation when you play it to music. So I found that to be a real disappointment. I don't know what this is meant for, but it has an audio out jack on the side here. I can't imagine what you use that for. Unless maybe if you do audio in here and you want this to then still feed the audio to something else. No idea. There's also a USB port on here. I don't know what they can use that for, unless maybe you can talk directly to the PC software directly. Again, without any documentation, no idea. This is the IR receiver, so you don't want to block this. This is how you can control your 3D animation. From this, you can turn it on and off, you can dim it, and you can pick a few other different options, but there's not much from the remote that you're going to want to use. So the next step that you want to do is verify that every LED is working after you've assembled the cube. It's possible that a solder joint could get broken. It takes quite a bit of work to get these levels installed into the pins, and it's likely that you may have broken one. I ended up breaking 2 connections. There's no built-in software inside the firmware to turn on every LED. What you have to do is they include a USB cable, and you're going to plug this cable into a PC. I'm running Windows 10. Then you load up this software, which is part of that download link that they provide. This software is garbage. It really doesn't work well. It's not supported. But it does work to turn on every LED. What you want to do is come over here to the COM port. It's grayed out right now, but when you first run it, you'll say scan port. In my case, it picked COM4. This says open port. It's open right now. That's why it says close port. So you click open port. I also checked real time. What you do then, you come over here, you click all on. It will turn on every LED, which makes it then a lot easier to figure out if you have a bad solder joint somewhere in there, if there's an LED that's not lit. I tried contacting the author of this program and he never responded. I was hoping maybe there was a newer version. This is the acrylic sheets that come with the 3D cube. They are covered in some sort of a paper sticky back stuff that you have to peel off. It's kind of a pain in the ass getting this off. It tears quite a bit. Doesn't want to come off too easily. Each piece is unique, so you have to line up every piece and know where it's going to go. Like this piece here is the front because it lines up with those switches, and it lines up with the USB port. So you have to figure out where each piece goes first. The bottom and the top are the only 2 pieces that are identical. You're going to have to peel off the paper before you assemble it because things have a slot and they go into the slot. They're not going to fit into the slot with the paper on. Now the problem is when you touch this, it gets fingerprints all over it. So you want to try to figure out how to assemble it and only get fingerprints on the outside. Because if you get a fingerprint on the inside, you're not going to be able to get rid of it. So it's going to be a little tricky. They also include a bunch of screws to hold it together. And I think this is going to be a little tricky putting this on. We'll see how it goes. Okay, when assembling the sides onto the cube, I recommend hanging it off the edge of the table like this. This way these tabs will come through the bottom piece more easily. You're going to put these little tiny screws in the holes. There's 2 on each side. There's no right angle tabs here, so it's just preventing this piece from sliding upward. That's what all the screws are doing. What you also want is a few small pieces of masking tape. Just tape the edges together so that it doesn't fall off. Otherwise, this is really hard to build as one person. Okay, it's all done. Acrylic case is installed. and I'm very happy with the end result. This is the front view, but you also get a very good view from the side, so you don't have to look at it straight on. This is running the demo that's included that you copy over to the memory card. The one thing I wanted to mention that I did not mention in the beginning of the video, I showed you the eBay purchase and it shows $99. That does not include the acrylic case. The acrylic case and the shipping for the whole product to the United States comes to $160. That also does not include the power supply. So you want to add in another $20 or so for a power supply and the power connector.